Romania. This is John. I'm in Central Texas today. It's early morning. I'm on a farm, so this is actually normal time for me. After I do this, I'll be going outside and feeding dogs and getting my chickens out and all sorts of things. If anybody ever wants to come to Central Texas, I got plenty of extra bedrooms, as long as you don't mind dealing with scorpions and snakes. Let's see, share. Okay, do you see my desktop now?
Yep. Now.
And you see the just maximized presentation?
Yes. It's full for now.
Okay, if for some reason it disappears, let me know.
Okay.
And I'll swap it out. I don't know, maybe who knows, the connection is what it is.
I'll leave you with the audience, okay?
I'm sorry, I didn't hear that. What was that?
I'll leave you with the audience.
Okay, great. Is there somebody in the audience or somebody that is just going to make sure if there's any problems that they shout out? That way I don't present to nobody.
Yeah, sure.
Okay, great. Thanks.
I'll be around, okay?
Have fun.
Thanks.
Thank you. Oh, good morning, everybody, or I think it's afternoon. I'm having my coffee, and you guys are probably going to be going off to have beer pretty soon, right? So this is a presentation on Catalyst design patterns, and just to give people another minute to walk in, and also maybe for people to talk a little bit. What I'd like to do is spend the next 2 or 3 minutes. If everybody could turn to the person next to them, or choose a person next to them, and explain to that person what they think a design pattern is. One person says what they think it is, and the other person says what they think it is. And let's just spend a minute doing that. So I'm just curious to know, before I start telling you what I think a design pattern is, I would like to know what you think a design pattern is, so that way we can sort of have a conversation about what that is and move toward a group understanding of it. So let's just spend 2 or 3 minutes talking with each other like we've all been doing probably all day. The noise seems to be dying down a bit. Are you all mostly done? You need another minute. Can somebody shout out? Don't be shy. You sounds like you're kind of... normally if I was in the room, I'd point at somebody, put them on the spot. So somebody in the front row, let's say 2 seats from the right side, tell me what is a design pattern? Unless that seat is empty, in which case then the closest person should just say it. I'm sorry, what was that?
Do you hear me here?
Perfect, yes.
Okay.
Go ahead.
So, from what I've discussed with my colleagues, what was this is that the design pattern is a recipe for applying best practices to common problems. That's how we have defined the design pattern.
You didn't look at Wikipedia, did you?
We did. I'm enterprise, so I know this by heart.
You're a Java programmer as well as a pro programmer. Is that what you're saying? No, sorry. What does the audience think? That sounds pretty good. Does anybody have anything to add to that? Don't be shy. They all seem to agree. That means you're all shy. All right. Too bad. Okay. All right. Yes, I think that's pretty good. So, a design pattern. When people started programming for money, like in the 70s, and particularly when we started to build more complicated web systems, GUI systems, the early work that was done at Xerox PARC, and then of course the Mac, and all those kind of things that came out. People were programming, and we had a programming language and different languages, but we started to realize that there were relatively common problems. And in the same way that when somebody goes to build a house or goes to install plumbing in a house, it's quite often that you, instead of building everything from scratch, reaching for well-known, tested approaches to certain problems tend to both speed up the work, make the work better, and make the work easier for other people to understand later on. So this is a talk about design patterns, both classic design patterns, as you may have read about in the books, and also design patterns that are sort of specific to Catalyst and Catalyst programming, and a little bit of overlap. So let's start to talk about Catalyst a little bit. Now, a lot of times people come onto IRC, or I worked a lot of Catalyst programs over the years, and one of the problems that I think people tend to run into when they first pick up Catalyst is it's kind of a big framework, and people are often asking themselves, people are asking a question that basically comes down to this. They kind of feel like that programming in Catalyst is almost like a language unto itself. It's like you're not programming Perl, you're programming Catalyst, right? But what I want to, hopefully by the end of this presentation, get people to think that programming Catalyst, you're programming Perl, but Catalyst is enabling and encouraging certain design patterns that may not be as strongly promoted in other frameworks that you might be coming to into Catalyst if you were as a pro programmer. Like if you were a pro programmer like in the 90s doing a lot of CGI programming, or maybe using Mason, or using other programming frameworks. A lot of those frameworks, they're just really aimed at hackers, right? You're sitting down and you're just hacking out code. Because Catalyst is built around a lot of these design patterns, it can sometimes seem a little foreign. Okay, so the concept of design patterns. The classic book is the Gang of Four classic book, came out I think in '94. Does anybody here have this book or has read this book? Nobody? Shout out, come on. I'm sorry, somebody said they've read it? They have it? You have the book, but you didn't read it. Or you read half the book and told your boss you were still reading it, right? Okay. Anyway, so although the Gang of Four Design Patterns book, this is a good book. It's worth getting and worth reviewing. There's probably at this point 1,000 design pattern books out there. Because like when this book came out, it started like this wave of like talking about design patterns. But I think it's still worth looking at. Now, this group, they didn't invent the idea of design patterns. The idea had been sort of floating around actually even from the late 70s and into the 80s. But this book was sort of like, this group of four programmers put down some very basic ideas, and they sort of codified the concept and promoted it, okay? So when I talk about the Gang of Four, when you read about Gang of Four design patterns, these are the classic design patterns that were described by these four programmers in this book. that I think is still worth reading today. Now, I'm not going to cover all the design patterns in this book. I'm going to talk about some of the design patterns and how they apply to Catalyst, and I'm going to talk about some design patterns that are specific to Catalyst that are not necessarily in this book, okay? But again, you know, I hope after this, this talk and you start to think about programming in Catalyst in a more structured, meaningful, logical approach, taking a look at this book is definitely something worth doing. So I think earlier today, I'm sorry, I didn't hear your name. Who was it that gave the definition of a design pattern? I didn't catch your name. Lloyd? Okay. What you said is basically, I just stole my definition on Wikipedia myself. But when we talk about design pattern, they're saying it's a formalized best practice, right? You know, just like when a plumber is going to install plumbing into a house, a plumber just doesn't get a bunch of nuts and bolts and pipes, you know, just straight pipe. They apply principles that plumbers have built up over, you know, centuries or even at this point thousands of years in order to solve problems and make sure that plumbing gets installed in your house in a way that works well, and you know the plumbing doesn't get backed up easily and it doesn't make a lot of noise, and it's easy to enhance. The same thing goes for programming. Now, a design pattern is not intended to be a specific, like, you know, write these lines of code, right? It's a pattern or a recipe, I think was the word that you used. That's used. Now, my background is actually not in computer programming. When I went to college, I got a degree in philosophy, and so I always think of design patterns as sort of metaphysics, right? It's like talking about programming. It's talking about programming that is programming itself, and so these are not going to be a design pattern. Is not going to be something that it's like you're going to copy an exact approach. It's going to be something that I want you to think about and think about how to apply it. Now, I think this is one of the things that sometimes when people go to use Catalyst, it sort of catches them off guard because in a way, Catalyst is not a great framework for like a hacker. I think Catalyst is a framework for a thinking programmer. And a thinking programmer is somebody that hears the problem they have to work on and thinks about the philosophical aspects of programming and how you put it together, okay? So let's start talking about some design patterns and how they are in Catalyst. So here's a design pattern called command. Is anybody familiar with the command design pattern? Yes. Okay, great. Well volunteered. You tell me what's a command pattern? You have to turn around. You can't look at my slides. Yeah, okay, that's pretty good. Okay, so a command pattern is I think that I try to tell people that if you want to think of a command pattern, it's an object wrapped around a function, right? So you might have a piece of functionality in your class, and that function is something that is cross-cutting. Maybe it might apply to a lot of different classes, right? But it's not something that breaks out either in inheritance or through roles. It's something that's sort of separate, okay? And it has concerns of its own. It needs to maintain state, or it needs to do some sort of bookkeeping, like you want to do logging, or you're using it to in some way inform the way your application is working, okay? So in Catalyst, a command design pattern is an action. So here's a example controller in Catalyst. Does this look mostly familiar to people? This is a quick question. Most people in this room, have you used Catalyst or looked at it? Raise your hand if you've never seen Catalyst before, and can somebody tell me how many hands are raised? There's one? Okay, great. So that's fine. Okay, so in Catalyst, I'll talk a little bit more about what a controller is in Catalyst when we talk about the ModelViewController design pattern. But just a controller is sort of the entry point for your client into the application. So when the client makes a request to Catalyst, usually it's an HTTP or HTTPS request, that request gets mapped to a controller by the application, okay, depending on what the URL is and depending on other aspects of the request. Now, in your Catalyst controller, that request will get delegated to a method, and this method, for example, list. So we've created a method here called list, and we've added this local decorator to it. So that informs the application what URL that this method is listening to. Okay, and in this case, when you look at it, the list, and when I say an action is is basically a method in a Catalyst controller that's been decorated with an attribute so that it can listen to a URL or to a request from a client. Typically, it's a URL. Okay. Now, in this case, when you look at this list action, you're noticing that it can respond to self, which is the controller, and the context. And the context contains information about the request and the response. Now, the context in and of itself is a design pattern, and I'll talk a little bit about that again later on. But the way this is put together is this method, okay, this subroutine list. When Catalyst starts, it looks for all the controllers, and it looks for all the methods and controllers that are decorated so that they listen to requests. And behind the scenes, it takes that method and it wraps an action class around it, right? So behind the scenes, every single one of these actions in all your controllers are actually blessed and created into action classes that the controller knows about. And that action class contains information about how this particular method matches a request and some other information about it. So I want to just briefly look at what the Catalyst action command class looks like. Now, I really recommend that everybody actually go at some point and it's all open source. There's nothing stopping you. Go to, MetaCpan or whatever and open up Catalyst action and actually look at the code. Now, I've sort of made it a little more simple so that we can talk about it. Okay, there's actually more methods and more going on in Catalyst action than this. And that will be the case, by the way, for a lot of the slides that I show you. I just sort of simplified it for the purposes of demonstration, okay? But in your Catalyst action, this is the information that it knows about itself. The attributes, which are the decorators, like let's go back. Oops. So the local, right, that's an attribute. You see here. That ends up in the attributes. Attribute. The class, which is the name of the class that it's in. The namespace, that's the namespace that it's listening to, right, for the URL, for the request. Code, the code is actually that's a reference to the method, okay? So all that information is taken and blessed into this Catalyst action. And we have some extra methods here. The two most important ones are execute and match, okay? So match is when your Catalyst application is trying to decide what action should be matched to a request from a client, like, for example, a URL. We run the match method, okay, on all those actions, and if the match method returns 0, that means this action doesn't match, okay? So this is a mechanism for you to add on and say how you want a method to match. And of course, execute, that's the method that gets run when Catalyst has decided, your application has decided, I found the action that matches the request. I'm going to run execute. Execute will then run the code for you, okay? I also threw in here list extra info. A lot of times people are always asking, when you start up Catalyst in debug mode and you get that, all that debug information that lists like all your models and views and controllers and all that, how everything puts together. Is everybody familiar with that? You've started application like with Catalyst _debug equals 1 or in debug mode. Has everybody done that or know what I'm talking about? Somebody said yes. Yes? Okay. Did anybody say no? Okay. So list extra info, that's basically information about what this action is matching. So that's actually called at that point. So again, when you create an action class, what I was talking about is a command pattern that encapsulates that method, but it adds more stuff to it to make it more useful for the purposes of your application. So I want to look now at just a couple quick examples of how an action is used in Catalyst, how a command pattern is used in Catalyst. So this is an action role, and this one actually comes with Catalyst. Okay, so generally, what I tell people when you want to customize the action class for your Catalyst application, it's best to use a Moose role rather than to subclass Catalyst action because you give yourself more flexibility. Okay. Generally, when you're using multiple inheritance, quite often it causes trouble. So this basically is better to use a role because then you're able to aggregate several action classes into your action if you want. Okay, so you might create a role that will wrap your original action class and provide some additional functionality. Okay. Now, in the example I showed you, I said that your Catalyst action defines a match method that is used for determining if the action matches the request. It's actually slightly more complicated than that, and you'll see it when you go look at the source code, which you're all going to do tonight, and tell me about it later on IRC. Because of the way Catalyst works, it actually runs two methods, match args and match captures. Okay, and I'll talk about the difference between those a little later on when I talk about chain of responsibility. But you end up having to wrap both match args and match captures in order to properly override or to wrap your match. Okay, so what's going on here? In this particular case, I'm making an action role that determines if an action matches the request by looking at the URL scheme, right? So the URL scheme, that is like, is it HTTP? Is it HTTPS? Is it, WS for WebSocket or WSS for WebSocket Secure or FTP or something else? I mean, generally in Catalyst, it's usually HTTP or HTTPS. You might be doing WebSockets, which is experimentally supported. So you might want to say that an action can only match if it's HTTPS, for example. So I'm going to look at the request environment and get the scheme. And then I'm going to get the required scheme. And I'm going to see if they're the same. And if they are the same, then continue. And if they're not the same, return 0. So returning 0 in match means that it doesn't match, right? So for yourself, you could use this to create your own action roles to do things like don't match if the person is not logged in, right? Or don't match if, unless their IP address is on a, whitelist of allowed IP addresses, for example, okay? Now let me show you how this is used in a controller. Okay, so here's the control that I showed you earlier, and here we are using the action role that we just looked at. In Catalyst, if you want to apply additional action roles to your action, you use the does attribute. Okay, and you can use multiple does attributes if you want. You can say does scheme, you can add as many roles as you wish, okay, to add more functionality to your action class. And then, of course, I'm just setting the required scheme. Okay, so this is an example of creating your own custom command class to customize how Catalyst matches or fails to match a given action in a class. So this is an example of matching. Let me show you. Let me show you a little more complicated example. Okay. Now you can override the match, and you also might remember from the earlier slide I showed you that you can also override execute. Now, when execute is called in your on your action, the things that get passed to the method include self, which is the controller, and context, and that which is the current request and response information. Who here else might be able to comment what an action might get from execute? Besides self and context, what else might be passed? Does anybody does anybody know? I'm sorry, what was that? Oh, right. So in other words, arguments, right? So like, for example, you could say args1 or args2 or captures or something like that, and you would get those passed, right? Okay, good. So when execute is called, it passes the arguments that are going to your action. Now, this is a little experimental class that I wrote, Catalyst Action Signatures. I always thought it might be fun if instead of just passing arguments, you could pass other things. You could sort of like command the action to pass stuff that you're using, like maybe the model or the view. So this is a little experimental module that I wrote that uses a Catalyst action role as well as the signatures pragma. And what it does is it inspects the signatures that the action is defining, and based on the signature definition, it's actually going to then inject information into your subroutine, into your action based on that. So instead of just getting arguments, for example, you could call for your view or for your model. So just to see what this would be the equivalent of. So these two are the same, really. If you took out Catalyst action signatures, you would get self, context, your arguments like normal, and then you could get the view by calling context view, and you get your user model by calling C model, and then go on from there. So this is just a little, come on. It's just a little experimental module that I wrote that overrides execute. It's basically, I'm putting it out here as like, I want to give you ideas about things you could do with it. I'm not sure you should use Catalyst action signatures. I consider it a little bit experimental, but if it looks like fun to you, please download it and give it a try. Okay, so let me pause for a moment and ask, are there any questions about the command design pattern and Catalyst actions? Or anything that you just saw that you want to ask questions about? You're a quiet group. Nobody's got a question? I can move on. Okay, so let's move on and talk about ModelViewController, right? A lot of times when people, when you talk about Catalyst, you know, when someone says, "Oh, what is Catalyst?" People always say, "Well, it's a ModelViewController framework." Like, you know, that's actually a big thing to say. Okay, so ModelViewController, in and of itself, is a design pattern it's sort of a pattern of patterns because it's built on many other patterns. And I'm introducing ModelViewController now because all the other patterns that I talk about later on are all in some way related to being used by Catalyst under the ModelViewController sort of pattern of patterns. Okay, and ModelViewController is it's typically associated with user interfaces. The concept was originally brought up when people were trying to build the GUIs for desktops. Okay, and the concept maps. It doesn't map perfectly to classic server-side applications because in classic server-side applications, it's more about separation of job duties rather than classic ModelViewController. Let me go through what that's like. So here's a picture of the classic model view controller pattern. Is there anybody in the room that is willing to stand up and explain what this means to the audience for me? I'm going to call on somebody in the second row to do it. Second row middle, you're on the spot. Can you explain this? Oh, go ahead. Okay, all right. Don't mean to put you on the spot. It's easier for me to do when I'm in the room. I can drag you up to the front with me. Okay, so in ModelViewController, the idea is that you separate the way an interface works into three separate components. Okay. Now here you have a user, which in the web server context, that would be like a web browser, or somebody using a web browser, or using a server-side client tool like Perl or something like that, right? So that person sends a request to your application. Your application maps it to a controller, right? The controller then picks an action from its list and executes it. That's the action pattern that command pattern that we just saw. Now, in classic ModelViewController, the controller gets the requests, it looks at the request, and it, if necessary, will manipulate a model. So, for example, if the request is like something like, I clicked on a button, or I'm submitting some form parameters, it'll take that information, perhaps doing some sort of validation on it to make sure that it's correct, and then takes it and will manipulate a model. So for example, you might post some form parameters that are intended to update a model. So you'll validate the form parameters, and if the parameters are good, you'll change the underlying model to represent that, okay? And then again, in the classic ModelViewController, you have a view, which, and again in classic, that might be a GUI on your desktop. The view is listening to the model for changes, and when the model changes, it updates itself, and people can see that. Okay. For your web server, particularly for server-side frameworks, it's a little different because your, as you know, HTTP is sort of like a system. You send a request, you get a response. So it's not it doesn't keep a continuous open channel to the user. So you get these discrete request responses. In a server-side framework, typically what ends up happening is your user makes a request to the controller. A controller will then take that request and either manipulate or query a model. And then instead of having the view listening directly to the model, it'll take the model and that's been requested or modified, send it to a view. The view will be responsible for preparing a response. And then the application sends the response back. Okay, so let's look at a very simple case in Catalyst. All right, so let's dwell with this one for a moment. Here's a controller. And this controller is listening to a particular URL that a client can request, right? When this action gets run, it does two things. The first thing that it does is it gets it requests from the user model certain information, a list of users. And it then simply takes that information and forwards it to a view. Okay, so let's look at the individual components of this. Let's look at the model first. Now I know typically with a Catalyst model, it's going to be more complex than this. Many people will be using like a database. You might be using DBX class. You might be using the DBX class Catalyst model adapter, and it's got a ton of other things in it. But just ultimately, when it comes down to it, all that a model is it could be as simple as this. It's just a class that's returning information, right? So it's a model. It's a class that's got a method called user list, and it's returning the user list. Now, I have it hard-coded here, but could be querying from a database. It could be loading this information from a comma-separated file in the file system. It could be getting this information from, I don't know, a RESTful resource located on a different server, right? But ultimately, a model is just a Perl object that's returning information. Again, a more complicated model will probably have the mutators, the ability to add and remove items from the user list. But I wanted to keep it simple for the purposes of just thinking it through. And again, here's a view. Now I know if you're programming in Catalyst, you're probably using a view adapter like Template Toolkit or XLit, and it's doing a ton of other things behind the scenes for you. But I wanted just to simplify it because again, a view in Catalyst, it doesn't have to be much more than this, right? It's just simply a class. In this case, I'm creating a method called process. The process method is what's called when you forward to something, okay? When you forward to something, you actually get the context. Unlike when we call the method on the model directly, you probably noted that you didn't get the context, right? So I'm getting the context, and I'm just creating a response. And again, I'm hard coding it. It probably is not the approach you want to take if you have a big team and a lot of a lot of users. But again, ultimately, it doesn't need to be more complicated than this. Okay, I'm just creating an HTML page that's returning the information that's sent to it. Okay, so these, just putting it together, it's just very simple. So let me just go back. Okay, so just to go back to it, right? You see how that's coming together, right? The controller is listening to the client, and when it gets a request, it gets information from the model. It might change the model, okay, first, if it's post, right? You might do a lot more with it. You might have to do some sort of validation. You might need to check, do things like check if the user is logged in, and all sorts of other things. But everything that you're going to be doing in Catalyst is going to start at this level and build outward, right? You're going to be building on top of this basic pattern. So it's worth just thinking that using Catalyst really is just as simple as what I'm showing you right here. Now I'm calling the user model on the first line, and then I'm forwarding to the user's view, and I'm sending it the list of users. So again, the model. Not a lot going on here. And the view, and that's it. Okay. Does anybody want to ask any questions about any of those 3 slides where they don't understand some aspect of it? Okay, I'll go forward. We'll keep some time at the end as well for questions. You can look at slides. I know it's a little hard to sometimes say it. So I said before that Catalyst, my ModelViewController is sort of like a pattern of patterns. Okay, one of the other great patterns that are in Catalyst is the chain of responsibility pattern. A chain of responsibility it's an abstraction as I'm writing here. It decomposes a complex workflow into discrete objects. And it's intended to promote loose coupling of design, and it simplifies your action. Okay? So let me give you an example of what a chain of responsibility, a very simple chain of responsibility might look like in your Catalyst application. Who here is familiar with chaining actions in Catalyst? Has anybody here actually ever used chaining? Okay, you said yes. So tell me, what is chaining? In general, that's yes, very good. Okay, so in chaining, I said before that in your Catalyst controller, you will define actions, and that actions are instances of Catalyst action, and the Catalyst action is a type of design pattern called the command pattern. Now, one of the things that's really great about Catalyst, and as compared to most other web frameworks, is that when you create your action, you're not limited to saying that there's only one action that can be linked to a request, right? You can actually create a chain of actions that all handle a certain part of the request, and you can describe them as being connected together. Now, here's an example of pretty simple chain where when I'm requesting something, it's going to take one of two paths, okay? If it's a get, it's going to go first to the subroutine, to the method root, and then it's going to, after it then executes that and does that stuff. And if it's a get, it will then execute the action summary list. But if it's a post, it's going to execute the action add. Now, in Catalyst, when I do chaining, it's typically a lot more complicated than this because usually you have more than one controller in your application, and you can actually chain across controllers. So you could create, like, say, a top-level chain in at the root of your application, and then you can chain that all the way down. And that's actually the method that I promote and tell people is probably the best approach to Catalyst. I wanted to keep it, again, simple for here. But the way this simply works is that with the action root, I'm saying that it's chained, and chain slash, that's saying this is the start of the chain. And the action summary list and the action add, they are saying chain to root. So in other words, they're saying that I'm the next chain link after root, okay, for this particular request. And I'm adding get and post, all right? So basically, the way this is going to work is I get a request, and if it's a get, it does root, and then summary list, and then if it's a post, it does root, and then add. All right, so what's going on here, and how is this broken up? When you first get to root, I'm doing the stuff here that is common. So both summary list and add are going to want to have a view, okay? Because you want to when the user does something, you want to respond, right? Just again for the purposes of creating a demo, I'm creating a view called summary list, and it's expecting to get the information that's in the model. And then if it's a get, I'm simply saying, go ahead and return an HTTP OK, and generate the view with an OK. But if it's a post, I'm doing something a little bit more complicated. I'm checking to see if I'm calling a form model to inspect the post and decide if it's valid. And if it's valid, well then go ahead and return OK. But if it's not valid, I want to call the bad request method instead and tell the user that your form parameters are bad. Okay. So as you can see here, in using chaining, it makes it so that you can sort of break these pieces up into easier to understand bits, rather than having to have a root method where you're doing a lot of logic to say, well, if it's a get, do this, and if it's a post, excuse me, if it's a post, do that. By breaking it up like this as well, it makes it easier for you to use other composition stuff, like you could use moves roles, or you could use command patterns on your actions in order to break things up, okay? Now, one thing is, whenever you do an abstraction like this, I always try to warn people, you want to be a little careful about, you want to use enough abstraction so that you simplify the workflow so that somebody reading your code can understand what's happening, okay? So in other words, you would like to try to abstract out as much of the superfluous stuff so that you reduce the noise so that somebody looking at your code can sort of follow it, okay? Just like if you're reading a book, you want to be able to follow the action without a lot of, random details that are not helping the action move along, right? On the other hand, you don't want to add so many abstractions that people can't understand what's going on without going and looking at all your abstraction code, right? You end up with a rabbit hole of abstractions, and then nobody can debug your code, okay? So, when using Catalyst and using all these design patterns, you have to choose a really good balance between following good design patterns and good practices, but not overly abstracting or overly complicating your code to the point where other people coming after you can't understand it, okay? Try to shoot for something where somebody can look at your code and follow what it's trying to do. Any questions about how this particular controller works in terms of chaining? There must be a question about chaining because people always tell me they can't figure out how chaining works and they don't want to use it. How many people here are afraid of chaining? Okay. Yeah, it's. I understand that it can be a little bit intimidating because the way that you describe how chains work, the attributes, it may not be as it's probably not super user friendly in terms of how you describe it. Okay. Unfortunately, I've never been able to come up with anything better than what Mattrap did on day one. If anybody does come up with something better, feel free to come talk to me about it because I would love to try to make chaining easier for people to use. What I really recommend is for people to look at this example and dwell with it, okay? Because if you can sort of understand how this works, you can build upon it to make more complicated chains, okay? But ultimately, what it comes down to is you're creating the start of your chain, and you're adding methods to it. You're adding actions to it by describing where you're coming from. The information that goes into the chained attribute, you see like here, for example, it says chained root for the summary list. That information that's inside the parentheses there, it should be the private name of the action that you are chaining from. If you want to chain from an action that's inside the current controller, you can use a relative private name, which means typically the relative name will simply be just the name of the subroutine of the method. Okay, but you can actually put the entire private name of the action into the chain as well, and you can use that for when you're chaining across from other bits. So the private name of an action is the name that Catalyst gives it, and that's typically the namespace that it's listening to. Any other questions about this example or how it works? And how am I doing on time? Okay, we're doing okay. All right, well, you said you had no questions. Everybody understands it. No more questions? We can talk about it later on, too. All right. Now I want to spend what is probably going to be the rest of the presentation talking about Catalyst components, right? The idea of a component and how components are used in Catalyst, it doesn't map neatly to one of the standard Gang of 4 design patterns, but the Catalyst components are built on top of some concepts of design patterns, and I'm going to mention them, but I want to spend mostly talking about what a Catalyst component is and how it's used in component, how it's used in building in a Catalyst application, right? So basically, a Catalyst component, it's an abstraction for an object, and the intention here is you want to decouple the creation of the required object from the code that's using it. And if you wanted to sort of think about what design, what classic Gang of 4 or what design patterns that are associated with Catalyst components, you may want to go look at dependency injection, service locator patterns, I'll talk about that a little more in detail in slides to come. So what's a Catalyst component, and why would you use it? Okay. So here's an example of a Catalyst controller. Okay. It's actually almost exactly an example that I've seen in an application. Okay. This is an example of somebody not knowing how to use Catalyst components properly, right? I'm sticking here, with the user controller and the list method, okay? And here is somebody that's writing a controller where they're trying to, the model is some information in a DBX class schema. So in other words, it's some information from a database, and they want to get that information from the database. So what are they doing? They're using DBI. They're using they're using Postgres for their database, or they're using the Postgres. They're using the schema that they've created, and then down here in the list method, they are creating an instance of the schema, and they are hard coding the connection information, including the password, which is terrible, and then they're calling the method on schema to get the result, the user result set. Okay. This is an example of how not to properly use the Catalyst components to build your application. Let me show you what it would look like when we change it to be proper Catalyst. So, really, if you're building your Catalyst application properly, what you want to do is to isolate all those bits about your model, and your model, how the model is created and how the model is instantiated and all that, behind a user model component, okay? So in other words, you're going to take all these bits out, and they're going to be isolated to another part of the application, and it makes it so that of course, your controller is now smaller. Okay, so less code is always good, right? Because it makes it, in theory, easier to understand and less to maintain. But that less code is not the key parts. The key aspect of this is that you've now decoupled the creation of your model from how you're using it, okay? And that means that you're programming against an interface, not an implementation. What it means is you can change the underlying implementation without having to change all the code that's using it, as long as you maintain the interface. Okay, so as long as you have a model, as long as you have a user model, okay, that is working like this, you can change the model from using DBX class. You can maybe instead point to a web service, right, that's returning the information, right? Or in your testing, when you're writing test cases, and if you write test cases and say you want to mock the database, you can create a mock class for testing, right? So you've isolated that. And I always tell people that when you're programming in Catalyst, particularly in your controllers, you want to be asking yourself, am I using an interface or am I using an actual implementation? And as to the most part, using an interface is what you want, because you want to be able to change the underlying implementation and how it's created. This will promote strong decoupling in your application, make it easier to do things like change your application, use a different model, you can use a different database, or you can even change it to point to a totally different type of information source. Now, I want to talk a little bit about what a Catalyst component is. Again, I really recommend that people go and look at the open source code and look at what a Catalyst component is. I've simplified it here for the purposes of talking about it. All that a Catalyst component is, it's just a regular Moose class, right? That defines some extra methods. In particular, it defines a configuration method, and it must define a component method. It may optionally define and accept context method. Let's talk about each one of those in turn. Actually, let's start with component. So, what is the component method for a Catalyst component? when Catalyst starts up, right, you have your application subclass. So your application subclass, that's your class that where you're saying use Catalyst, right? And you know it's typically in the root of class of your application. When Catalyst starts up, you know, when it first starts up, the very beginning, one of the things that it does is it executes all these setup methods. And in particular, one method is the setup components method. The setup components method will look for every single component in your Catalyst application. So it looks for all the models, all the views, all the controllers. It loads all of them, and in turn, it will call the component method on each and every single one of them. The component method should return a class, which is quite typically an instance of the model or the component class that you're creating, okay? So, and it gets the configuration information, which is, which will be a merged version of configuration that you're defining in the class and in your application, or if you say you're using something like a config loader, it's to have some of you use the config loader plugin. Anybody know what the config loader plugin is? I know one of you does. Somebody said something? So the config loader plugin is it's a plugin that you can get for Catalyst that allows you to put your configuration into files. So for example, you could have configuration information for your database, like the username and password and the location, and that information can be different for different environments, right? But that's not the most important part. We get your configuration from all these different places. But for a component, you're going to call the component method, and it's going to return an instance of the class. Catalyst will take that class instance and keep it, okay? Now, optionally, you must define a component method, but you can also define an accept context method. And what an accept context method will do is when you actually call for your component in the context of a request, okay, the client is requested. The accept context method will be called on your component, and you'll get the actual context. So if you look in your context in your component method, you get the class, which is the name of the class, and you get app. That's the name of your application. Okay, these are typically strings. In accept context, you're going to get self, which is an instance of the component that you're creating. And you're going to get, instead of application, you're going to get the context and any arguments that are passed, okay? So this is a great place for when you have components that need to know about the context. Like you want to know things about the request or the response or related information, okay? About the actual request that's going on. I'm going to give you examples of that in a moment. But let's look at a simple component. Okay, so all model views controls inherit from Catalyst component. Let's see. Let's talk about component lifecycle. So remember I said that when Catalyst begins, it's going to call up setup components, and it's going to call the component method on each and every component. Okay. Now, when you're calling for components, you can depend on the stuff that's passed inside your configuration is typically literals, like a DNS string, or a username or a password. But you can also depend on other application scope components. So for example, you could if you have another application scope component, you could make that a dependency. When you call for these components, you really can't, that are application scope, you can't pass arguments because it's already created. Here's an example. So generally, when you're creating a Catalyst component, I always say it's better to create an object and to use something like a Catalyst adapter, which we'll talk about later, but here's just a simple example. So you have a model, and it's using moves, and it's extending Catalyst component, okay? You probably would actually extend Catalyst model, not going to make a big difference in this case. You're defining three attributes: version, license, and copyrights. This might be meta information about your application. Okay, you're saying that these attributes are required and they can't be changed. So how might it be stored? How might you use this in an application? In your application subclass, you would define what those attributes should look like, right? So 1.001, the license is the GPL, and the copyright is 2016. When Catalyst starts, it's going to grab the configuration information for that model, and it's going to pass it to component. Component then is expected to call new on the actual model itself with these configuration information, so that it'll populate those attributes, version, license, and copyright, with this information that you're passing to it. And here's an example of how you might use it in a controller. So you would call for the application meta model, and you would get it as an instance, and you could call methods on it. In this case, it's just a method which is representing an attribute. Obviously, it could be much more complicated than this. You could do a lot more things with it. But when it comes down to it, an application scope model is just when Catalyst starts, it creates a model, and it creates it once, and it's fixed for the entire life cycle of your application. Questions about this before we talk about the next layer of an application component? So besides application scope, which is what is the default for your components. Remember I said that your component can define and accept context method. When your component defines and accepts context method, it then becomes what I call a context scoped component. And what that means is that when you're calling it, it will call every single time you request it in your application. It will call the accept context method and pass context. And then you can do things like within a context scoped component, it can have access to the context, so you can depend on literals, actions, other application scope components, even other context scope components. And it gives you a way for letting your model have aspects of the context available. Okay. One of the more common questions I get, or either on IRC or people are asking me, is if I have a model and I want to have the context in the model. I always say, and people say, well, it's a bad practice to send your context to your model. But what you could do is create a context scoped model that has access to the context that then provides to your model context information, okay, that's necessary for your model to function. So you don't want to pass the entire context to your model, because I think that promotes, that does not promote loosely coupled to well-designed. It promotes strong coupling in design. But you can create a context scope model that has access to the context, that then gets information from the context and passes it to your model. So let's look at an example of that. So I'm just, again, this example is slightly contrived, but I wanted to build upon the example we just looked at a minute ago. So I'm taking your application meta model, okay, and it continues to have three methods, three attributes: version, license, and copyright. And those bits are going to come from the application like before. So in other words, they're created. But we're going to add another attribute called requests, total requests. So, and the total requests is going to be provided at the moment that you call for it, right? So Catalyst has a method, no, that's not a method, I'm sorry. It's there's a variable that counts the requests for you. and so you can get a count of how many requests your application has served since the application was started. So here, in my accept context method, I'm getting the self that was created earlier. I'm getting the context arguments, which we'll talk about later, and I'm going to return a new version of itself that has all that information, but it also has the request information. So you see that request information comes from the context. I would generally prefer to break this up a little bit, and instead of having instead of like overloading it that way, I might actually create a separate standalone my application meta class and call that separately. So just to go into it here, I'll create my application meta that'll have the information that's necessary for it, and I'm returning a new instance of that in the accept context rather than overloading the actual class. And you'll see later on, as you build applications in Catalyst, in general, it's better to try to think of your models or views, or basically all your Catalyst components. Try to think of them as proxies or factories for underlying business objects that you define outside of Catalyst. If you can do it that way, it's great because it makes it easier to do things like test your models. Or, for example, you could reuse this application meta outside of Catalyst. Now, in this particular case, you probably wouldn't reuse it because it's request information. But if you were creating other models that you might say want to run in a cron job, or you might want to use outside of Catalyst, you would like to be able to do that. So this is an example of it. And again, here we are. Here you might define the application meta class outside of the Catalyst concept. Sorry, I had a slide here somewhere in how you're using it, but in your controller, you could just call the total request method, and it would give you the number of requests that have been started by that have been served by the Catalyst application since the start, and that's obviously tied to the context, not just to the application as a whole. So when you're talking about context scope components, one thing that's interesting is that you can use this to build all sorts of other things, like components that are scoped to session, scoped to workflow, or even ones that are scoped to the application. You could always just return the application. And as I mentioned before, that you can, when you're using an application scope component in your accept request method, you can depend on other components. Okay? But you got to wire it up all manually. And I do want to warn you that since you have to watch out for performance, because when your application does accept context, that means you're creating it new every time you request it. So that can, obviously every time you're creating a new object, you're eating a little bit of performance. So one way to sort of mitigate that is you could sometimes when you're building stuff in Catalyst, you want to accept context, but you don't need to build the component every single time within a context. You maybe just need to build it once. So here's an example of what we call a per request lifecycle. This is the hard version of it, and I'll show you the easy version of it in a moment. So here, what we're saying is, when I call accept context, I'm going to look in the stash and see whether I've built it or not. If I haven't built it, I'm going to build it by calling the return instance method. Otherwise, I'm going to just build it. Okay. One thing I wanted to show you here is that before I said that your accept context method gets the context, it's generally considered good form to make sure that you have a context, because there are some cases where you might not. So you need to be able to handle whether or not that second argument is a context or not. You need to be able to handle it. Even if you simply say die, I need a context. This pattern was so useful that I think it was Matt Strauss who got tired of explaining it to people over and over again on IRC. So he talked somebody into building a little role called the Catalyst Component Instance Per Context that encapsulates this little piece of information. And it defines a method called build per context instance. And it basically will do everything you see here, it will do for you. So you'll be creating, basically you get the context, it'll create a new instance of the model of the component for you, but it will only do it once per context rather than every single time you call it. So I know that was complicated stuff. Who's got questions about Catalyst life cycle? We can, again, I'll hope that's time at the end. We should have time at the end here for questions. All right, now I want to talk a little bit about dependency injection, which is again, it's building on the concept that we've just talked about, and maybe it's a little more complicated. So here's an example of a model that you might create. Anybody here use the HTML form handler? Yes. Okay, yeah. So HTML form handler. Gerda Schenk wrote this. It's my preferred way for creating models that do form validation. It actually does more than that. It does form validation. You can use it to create views of your form, and it will even do things like update your model for you. I'm not going to go into detail about how form handler works, but I'm just giving you an example. Here's an example of a form handler model that it needs a user result set, and it has two fields, name and password. So this is like what a login form might look like, right? You'll have a name, it's got to be a text, password, it's got to use the password field. It requires a user result set because you might be doing some additional validation, like for example, making sure that password is actually associated, with the name and all that. So it requires a user result set and those two fields. And here is how you might create a model for it in Catalyst. Now, again, like I always say, it's best for your model if your models wrap underlying business objects. That's what we're doing, right? We're using your My App login form, and you're creating an accept context method that is going to create that form. And when it calls process, now process is the method that is a method that HTML form handler defines that will then do the validation for you, right? So if you've used form handler, you've probably used this before where you pass the parameters. And in this case here, I'm just creating a model that's passing the parameters for you, right? So that then, when you call it, for example, in a controller, you simply just say, my form is model login form. And you can immediately then check to see if something is valid or invalid and move forward, okay? This is, in my mind, the way when I say like you should be encapsulating and working against an interface, not an instance. What I generally see people do is they'll actually, in their controller here, they'll say, use my app login form, my app login form new, my app login form process, and they'll gather all the, in other words, they'll stick everything there inside all that instantiation stuff. They'll stick it here in the app, in the action. And I can never fully understand that because it's like, in my mind, you're not really taking advantage of what Catalyst gives you. I would recommend encapsulating that into your model and isolating it so that not only you simplify the process here in your controller, but you make it so it's like you want to be using an interface, not an instance, so that maybe someday down the road, maybe form handler becomes not the most popular way to do form validation in the future, and there's something new, form handler 2 or something else. You can change the underlying implementation to something totally different without having to change all your controller code, right? Do you see how that would work? I mean, as long as your MyApp model login form can turn something in your accept context that returned the interface that was required, you could totally change this. This could be something completely different, right? And this would continue to work, right? So 5 years down the road, when you're changing all your code, you can change it at the adapter level without having to go into every single controller, okay? So we always say the best practice is not to actually write a model, but to write a class and use a model adapter or model injection. I think we're running a little short on time, so here's Catalyst model adapter, which gives you, which encapsulates the 3 most common patterns, which are application factory and per request, and they give you a method for doing that, okay, which makes it a lot easier to do the right thing. So when you're building Catalyst model, now just to be clear, Catalyst model adapter, you could use Catalyst model adapter to build models, but it really should have been called Catalyst component adapter because you could actually also use it for views as well. And if you want to be more experimental, they're built into the newer versions of Catalyst. You've actually built some of this component injection into Catalyst in the newer versions. And there's a plugin that is designed to help make it so that instead of using Catalyst model adapter, you can define everything with configuration. So one thing that people complain about with Catalyst, they say, I got to build a lot of classes just to do simple stuff. I like Catalyst model adapter, but if you want to build more things just by using your configuration, you could go and experiment with Catalyst plugin injection helpers with the newer version of Catalyst. It's got to be at least 990 if you want to experiment with that stuff. Okay. So just to give a quick example of what what this experimental stuff that's built in Catalyst looks like. There's in the newer version of Catalyst, there's a new package level method called inject components. So you could directly, instead of having to do a subclass of Catalyst model debug schema, you can just simply define it. So you could say I'm injecting a component called model schema, and it's based on a component called Catalyst model debug schema. Okay, so you don't have to necessarily go in and actually create that subclass if you don't want to. You might want to because you might want to customize it, but you could also just simply inject it and you could save yourself the extra model. You could always go in and create the model later. If you're using the injection helpers plugin, you can then actually say I'm creating a model called entities and it's based on a class called MyApp entity. So it'll go in and it will inject it and it will create all the information here necessary to create the actual model for you using basically just configuration. So you have 2 approaches, right? Actually 3. You could write your models by hand. You could create your component method and your accept context method. You can use Catalyst model adapter, okay, to encapsulate, or you can use Catalyst component per request. So those 2 to encapsulate building it for you. Or if you want to use some of the newer features of Catalyst, you can define it exclusively through configuration. This last approach is the least battle tested. It's newer. I would love for people to try it out and help me make it better. And this would just be an example of what the entity model underlying it might look like. You would just define it, and you could use it directly in your controller. So, okay, we're running low on time, so I'm just going to call it. Catalyst uses a lot of design patterns. I've only talked about a couple of them. It's actually using other design patterns as well, but I think those are some of the ones that I talked about are the ones that I think are often confusing to people. So I want to give you an opportunity to go through it. Let me leave some time here for questions from you. Does anybody have questions about any of the design patterns, or want me to go back and look at one of the slides and talk about it more in detail? Somebody's got to ask me a question, or I'm going to feel really bad. Don't be shy. Okay, you can always find me on IRC. I'm usually hanging out on everybody know where the IRC Catalyst channel is? Yes? Okay, if you don't know where the Catalyst IRC channel is or how to get onto it, just ask somebody in the room that said yes, and they'll show you. Usually hanging out there, so feel free to come ask me any questions about any of this stuff that we talked about, or you can talk about it more in detail. Otherwise, I'm giving a presentation tomorrow, again on Catalyst, where I'm going to use some of these design patterns to actually build an application, or what I hope to be is a modern version of a Catalyst application. So if you're interested in seeing how I might use some of these patterns in a real application, feel free to come to that. If you're tired of hearing my voice, you don't have to come. Otherwise, I think we were pretty much out of time. So if there's no other questions, or if you're too shy to ask questions, we could just call it.